Hello, my name is Victoria Fliss, and today we will be learning about problem geometry and setup. Before we look at a problem, let's discuss what this section entails. Problem geometry and setup includes a diagram that defines all geometric and directional equations that you will need to solve the problem in later sections. You want to be sure to include geometric variables which define distances, such as S1 or L1. Direction vectors, such as M, N, P, or Q, are bolded letters that define the direction of forces or other helpful directions needed in the problem. Remember that direction vectors are always unit vectors with a magnitude of 1. You should also include position vectors, such as R1 or R2, which define the location of various items of interest. You can see that geometric variables are not bolded because they are scalar quantities. You want to be sure you do not include forces and moments in this section. Let's take a look at a problem. This is a bar supported by a ball and socket joint at A, and two cables, BD and BC, with a weight hanging on the end. The first step in creating the problem geometry is to determine what we know from the diagram. We know that a ball and socket joint creates a reaction force with an unknown direction at A. We will need to find the direction of the two cables, as well as create a position vector along the bar. First, let's find the direction of cable BD, labeled as P in the diagram. The direction of the cable is a unit vector from D to B. By definition, the unit vector is the vector divided by the magnitude. We can find the vector by subtracting the coordinates of B from D, because we want the vector to point towards D. For example, in the E1 direction, we have 0 minus 4 equals negative 4 E1. We can find the magnitude by finding the square root of each of the components squared. Once we divide the vector by the magnitude, we get our direction P. Next, we can apply the same logic to find the direction of cable BC, labeled Q in the diagram. Once again, we find the vector from C to B as shown here. Divide this by the magnitude in order to find the direction Q. Finally, we want to find the direction along the bar. Although there's not a force acting along the bar, we will use direction M to help us define the position vector in the next step. Find the vector from B to A and divide it by the magnitude in order to define direction M. Our final step is to find the position vector. Position vectors are used when calculating the moments caused by a force using the R cross F formula. Our goal is to define a general R vector. To create this position vector, we need a magnitude and direction. We use the geometric variable S1 to define any position along the bar as our magnitude. The direction is signified by M, which was found in the previous step. Therefore, our position vector to any point along the bar is R equals S1M. We now have our final problem geometry and setup information.